Hello, this is Group 10. My name is Hunter Wilson.
Hi, I'm Lana Fakhouri.
Hi, I'm Ehab.
And the name of our project is OpenCV Chess. To introduce our project, we wanted to design a program that could oversee a chess game, and mostly like a referee would do, making sure that every move throughout the game was legal throughout the game. To start our program, there is a user interface that pops up saying computer vision chess with a button that says start a new game. Once the player hits start a new game, it will ask the player to clear the board for initial game setup. This is so the program could analyze the game board before any of the pieces get on. Live footage will show up on a frame showing that your chessboard is in the center of the screen. You'll then hit Q, and it will analyze the chessboard, showing all 86 corners on the chessboard, also with all 64 squares, each giving them a letter and numerical value and a region of interest in the middle of the square that will later be used to find the BGR value on each square. Then the player will have to set up the game board, which through the power of editing will only take a second. And after that, the user will hit done, letting the program know that the game is now set. It will then take a photo of the game board at its initial state, giving each of the values, each piece on each square, a specific position on the game board. We'll then show what happens if you make an invalid move, say moving a pawn diagonally at your first turn. You'll hit done. It will then take a new photo and compare it to the original photo and take the BGR values and find the new location of the piece. In a second, we'll say that was an invalid move and that you can try again. Next, we'll try a valid move, say moving a pawn 2 spaces forward on the first move. Again, the player will hit done. It will take another photo of the chessboard and compare it to the initial photo. Eventually, the screen in the top left will update. Once it's updated, then we can scroll down and show that the game board has updated inside the program. Then will be the other player's turn. So we'll move, say, a pawn on the other side, 2 spaces forward. And then again, we'll hit done. And it will take another photo of the chessboard and compare to the frame before, the position of the chessboard before, so it makes a new original and current photo and updates the game board. Next, we'll show what happens if you take out a piece, say attacking the other player's pawn with your pawn diagonally. And we'll just put that off to the side. And again, we'll hit done. It's going to take another photo and compare it to the last photo taken. And it will update, showing that that pawn was taken out. Lastly, we're going to put the queen in a position that puts the other player's king in check. We're going to hit done. It's going to update, moving that queen along the board. As seen here in a second. See, it's now updated in the top left and on the program down below. And lastly, now, since that king is in check, there is no valid move. So we can try, say, moving the king diagonally there, but it's still going to be in check. So we're going to try that move as a last resort. We're going to hit done. And it's going to update, say that's an invalid move. You can hit try again, but there's no valid move. So you just hit end game, and it will prompt that that was a good game, and it's a game over. We're now going to do a live demo. Let me 1 second. Let me turn off my video, plug in my webcam, and switch over to OpenCV. All right. Let me restart and run. And all right, so it pops up with computer vision chess again. We'll hit start a new game. Again, the initial state of the board is going to pop up. This is what is expected. We'll hit done in a second. So this program moves kind of slow because it's going to turn on the camera and off the camera over and over again to get different photos throughout the game. So right now we're waiting on the camera to boot up. It's going to then show up a frame on the top left showing the live state of the board. In just a second, however long the webcam takes to boot up. So the webcam's on the tripod, looking down at the chessboard. Live feed right now. We'll hit Q since the board is in the center of the frame. And it didn't work. It's never not worked. Yeah, let me restart the program one time. Could be a lighting issue again. I mean, it seems to be the pattern of the day. So I'll try it one more time. If it doesn't work, we'll just move on to the presentation. We showed it in the video demo. Wait again for the webcam to boot up. What it could have been was when I switched over to from Zoom, I plugged in my webcam and it might be still trying to use my dashboard video, but we'll see. Let's see, it should pop up any second. Maybe. All right, I guess maybe it's not working today. We will just move on to the presentation and continue from there. We're just going to present. What's this?
So this is the importance of recorded demos.
Yeah, absolutely.
Live demos not always work, but you had record of your work there.
Yeah, it was working this morning and last night, so I don't know what happened. All right, gonna pass it over to Lana, and she's going to start the presentation.
Okay. Hi, everyone. So as Hunter mentioned, we are designing a program that oversees a chess game and warns players if someone makes an invalid move. This program is useful in teaching the game. And then chess is a one-on-one game in which a player takes turns strategically trying to trap the other player's king piece. And the chessboard and chess piece recognition is implemented using Python and OpenCV. So as far as the design, you guys can see the two images below. Chessboards are labeled by letters vertically and numbers horizontally. Each square has a label, and the design process detects each move, and it records its old and new location on the software screen. The design includes all details and labels of the breadboard, and it adjusts the pieces in their right positions. For the game rules, the chess program helps beginners like me learn the game rules. So when making a wrong move, the program will give you a warning message so you can avoid any mistakes from happening. Rules are implemented as codes with messages to determine the wrong moves. So once the move is fixed, the warning message will disappear. And then also a thought was made about implementing sounds to the program, but for the sake of time, we couldn't implement it. And then these two photos below show how each chess piece could be moved the right way. For game modes, it can be played one way, which is a human versus human mode, and the program will only read the moves on the screen board. After each player makes his or her move, the camera will read the move and stop his or her turn to switch to the second player. Also, a thought was made about implementing the human versus chess engine feature, but due to little time, we couldn't make it work. But if it were to be implemented, the program will make its move after reading the move the person in charge of the program implements. Python was used for the coding aspect of the project because the software supports many features related to the chess game. The software was used to write code recognizing the chessboard, the chess pieces, and user interface. As far as project weaknesses, there's a delay in determining the move locations since the only input support in the program is the camera, which has to boot up and shut down multiple times after each move. A solution could be connecting the chessboard to a computer and provide a sensor by each square to read the moves made directly. This can be achieved with more time. And also we failed to include the chess engine player option to the project for code complications and not a lot of time.
All right, here's the project structure, and it shows two different modes. The first mode is a human versus a human and how it works. When the first player makes his first move on the real chessboard, then the project, what it does, it captures a couple images and convert the movement on the monitor after locating the new pieces locations. Uh, After that, there are two different options. If the move is legal, uh, then the program can successfully convert it. If it is not, then the project stop and shows a message to warn the player about his illegal move. And for the second object, which is a human versus chess engine, unfortunately, this mode couldn't achieve. We were close to get it done, but for some issues with the code, may just leave it. Also, I will give a short feedback about it, just in case we can do some more. Can you go back to previous slide, please? So I'll give a short feedback about it, just in case we can do some more progress on it in the future to make it works. So what the mode does, when someone makes a move on the chessboard, the chess engine convert to a monitor similar to what it does in the previous steps. But here, the chess engine will make his own move, then apply this movement on the real chessboard, then matching the engine movement. If it is not, then alarm message will pop up. Next slide, please. And here's our chessboard that we used. So with the white circles instead of using the real pieces, because we have tried to make recognize the pieces, but it didn't work with the black pieces. Also, the pieces are long, so they cover the board squares, so it makes the miss recognizing the correct location. That's why we replace the pieces with those little circles. So if you see those, the chess pieces, so a little bit long. Next slide, please. And first, when we started on this project, we worked on detection and recognizing the chessboard, then the pieces. So here it shows you these two photos, edge detection using canny edge, corners, and lines. Next slide, please. And here's the board detection. So if you see the board is providing with each square labeled intersected by number and letter. So each row has its number and each column letter. So 1 through 8 and A through H for the columns. So next slide, please. And here's the result. Chessboard. So after we located all the chess pieces, then we make a move. For example, we move the little circle in the middle of the chessboard. We move the 2 steps, then hit OK. The program, what it does, it takes a couple photos, then convert the new locations, and the picture on the right side, it shows you the P in the middle. It represents pawn. Next slide, please. And here's a picture for our not valid or invalid moves. So when the pawn just moves straight forward. So when we make a wrong move, the program will convert it as well. But here show you a message says error invalid move. So the only way to avoid that, we need to return the little circle to where it was and then hit a try again. Next slide, please. So for the conclusion, it is an educational project since it's implementing machine vision with the coding using OpenCV. Also, it is a fun project, can teach you the game rules and how it could be played. And to improve this project, can build a small robotic, provide it with a chess engine to make it more interesting and fun. Next slide, please. And here are our references. Thank you.
Alrighty, any questions?
Thank you, Group 10. Good job.
Thank you.
All right. So I have to say, so who's the chess champion in the group there?
I've been playing it my whole life. So that's kind of
Okay.
why.
So remind me not to play you then. Anyway, so let's open it up for questions from anyone.
I guess I can start if you don't mind.
Please go ahead.
When I first saw your title, I was thinking, how are you going to recognize chess pieces from a top view, right? Because they all look just round, I guess.
Right.
Now, you had little circles, like paper cutouts or whatever.
Right.
Does that mean that you have a lot of knowledge of the game programmed in, and you just recognize pieces by how they move and their starting position, I guess?
Yeah, Python supplies a module called Python Chess, which will handle a lot of the moves that make it valid or not. There's been a whole database that's already in Python. So basically what we're doing is we're taking the BGR values on each of the squares. So the white circles will show a big contrast compared to the, say, brown or tan squares. When moving, it will scan the two photos and see where the biggest change in BGR values takes place, and it will give that value to the square that was given, since each square has a RG region of interest on it.
Okay.
And then it will input the current position of each, like each square is basically inputted as an array, and it will be inputted into the Python module, Python chess module, and it will output whether it's valid or not valid.
Awesome. So a lot of knowledge programmed in. I guess a related question, you guys keep saying BGR, and
yeah.
Is that, you mean red, blue, green, RBG? Is there a reason why it's transposed like that, or?
Yeah, just how the webcam takes in the photo is taking it first as a BGR value, and
it's just the order that the camera manufacturers, or is that some kind of a standard maybe? I'm used to
RGB, right? It's just a different conversion
RBG,
of the color
right?
scale.
But it's the same thing. It's red, blue, green values of a pixel.
Right. It can be converted
to
RGB.
All right, thank you.
I do have to say that this is one thing you run into, the type of tool you're using in machine vision or image processing. Some of them process the image as RGB, some as BGR. So if you mix them, then you have weird colors, and then you quickly figure out, oh, the order has to be in a certain way. And we did that in the class. I think you are using Jupyter and OpenCV,
yes.
and I think it uses BGR instead of RGB. So yes, it is RGB basically. Yeah.
Right.
But Osama had a great point here that recognizing the chess pieces. I was kind of wondering too that why are you using circles? First of all, easy to recognize, especially if you have only 2 weeks of time. But you're using the starting position of the piece to know what that piece is, right?
Right.
So that's a good way to do it. Then you're done. Once you know where the piece is, you don't even have to look at the piece. Just see where it moved.
Yep. You just measure the movement by the different regions of interest, and it will input it into the program.
So you can play actually chess with checker pieces.
Right. Yeah. Anything. You could put literally anything on the board. It would work with normal chess pieces, but the chess pieces I had with this kit were also the same color as the chessboard,
Right.
and it would make it difficult reading a brown chess piece on a brown square. It just hard to tell that anything's there.
Right. We all know that you need contrast to recognize
Right.
an object. There is no contrast on black, right?
Right. Absolutely.
Right. Well, what kind of lighting would you do to recognize black on black? What kind of
What do you
dark
do?
field, front field,
Right.
extra credit? It's probably you're gonna highlight the edges, so dark field
Right.
lighting. So you wanna somehow recognize that there is some shape on that black to see there's a piece there, right?
Yep.
More questions for the group? So I have a question.
Yes.
Since you're doing chess here, what do you think is a good way for the chess engine itself, the part of the program which makes decision what to move? Like if you're playing against the computer, would it be better to have a rule-based system or a machine learning system here? Open to
Probably.
everybody here.
I put a lot of thought in probably a machine learning system. I didn't dive too deep into it because I found this nice tool of Python chess. But probably machine learning because it would get slowly better at the game, and then you could probably change the skill. I don't know. Yeah, I
So
would say probably.
the original computer chess players, the IBM ones, do you remember in a while back?
Yeah.
They were rule-based, right? So
Right.
they would play the chess many levels deep to see which is the better move. So it's
Right.
a prescribed, you look at your board, you know the rules, you apply it. Okay, if I make this move, where would I end up? If I make this move, where would I end up? But then you
Right.
have these Google Go. Go is even more harder than chess, if you think about it. They are machine learning, and
Right.
so they play differently. They look at the board and how humans play. We are not computing 10 levels deep in chess what would be the outcome
Right.
of all possible moves, but recognizing certain patterns and going with that. So yeah, that's an interesting question, is like which one would do better here?
Yeah.
Probably
When we were trying to
machine
design this,
learning one.
when we were trying to design the chess engine, it actually used rule based, so it would go through. We would make a move, and there's a Python chess engine. We just couldn't quite figure out how to work. It got close, final stages, but we didn't have time. But you would make a move, and it would try out a ton of different moves in the background, and judge the rest of the game. And it would have like say 1 millisecond to decide on a move and an output something. So it would do as many moves as it could try in a millisecond, and then output the best one in the program.
That sounds like a rule-based system. So
Yeah.
it's probably just brute force computing what
Yeah.
would be a better move to make. But any more questions for the group? Awesome. Great job, Group 10.
Thank you very much.